Let's look at another example of time value of money. In this example, I'm first going to show you how to calculate a question if it's compounded annually, and then how would you calculate it if the interest is compounded more frequently, like quarterly. So let's first deal with the annual compounding. Pause the video, read the question, and continue with the video. It says you invest $5,000 in a bank where interest rate is 5% per year. Interest is compounded or paid annually. How much money will be in your account at the end of 10 years? So we go through a series of questions. Our first question is this question asking for a sum of money now or a sum of money in the future? Question says how much money will be in your account at the end of 10 years. So this is a future, which means we're looking for future value. Next, is the amount involved a lump sum or an annuity? Are we putting in money every period or are we putting in money one time? We're putting in money one time, so this is going to be lump sum. And if it's lump sum, we don't need to worry about ordinary or annuity due because those are for annuities. Now let's look at the other factors. Principal amount is how much you're going to invest initially, which is $5,000. Interest rate, this is compounded annually, so we need to only put the annual rate, which is 5%. And then the number of periods, which is 10 years. Because interest is paid annually, the periods is 10 years. Now let's calculate the future value. Future value is calculated by starting with equal, then FV for future value. Open parentheses, and then it tells you what you need to type in. So we're going to start with rate, which we know is 5%, comma, number of payments per period is 10, comma, the payment, again, we're not going to make any payments, so our payment is going to be 0. We know that our present value, which is the amount that we invest now, the principal is 5,000. And then the type we can ignore because we don't care. We're not looking at an annuity. So future value, 5%, 10 payments or 10 periods gives you $8,144.47. So at the end of 10 years, the account will be worth $8,144.47. Now, let's tackle this question, but I'm going to change it up slightly. I copied that question that we just completed to the bottom here. Now I'm going to change the wording a little bit. So it says you invest $5,000 in a bank where interest is 5% per year. And we're going to say interest is compounded quarterly. That's the only thing I changed. How much money will be in your account at the end of 10 years? So let's go through this question again. I'm going to delete all these items. These don't change. The first two questions don't change. Is the amount asking for a sum of money now or a sum of money in the future? It's still asking for future at the end of 10 years. 2 says is the amount involved a lump sum or an annuity? Again, that didn't change. It's still a lump sum. Now let's look at these three numbers. First, principal amount. Principal amount is 5,000. That did not change. If you look at what we did here earlier, it's still 5,000. Now, interest rate and number of periods are definitely going to change. Interest rate. We know that we are getting 5% per year, but interest is compounded or paid quarterly. So to calculate the interest rate per quarter, we take the 5% that's paid per year and divide that by the number of quarters in a year, which is 4. So 5 divided by 4 gives you 1.25% interest per quarter. So whenever interest is compounded more frequently than once a year, you have to figure out the interest per the period compounded, in this case quarterly. If the question said semi-annually, that would be 2 times, therefore you divide 5% by 2, giving you 2.5 as the interest rate. But in this example, we divided by 4 because there are 4 quarters in a year, and our interest rate is 1.25. Now, let's look at the number of periods. We're looking at 10 years, so we know that it's 10 years, but how many times are we getting interest in that 10-year period? We're getting, for each year, we're getting 4 interest payments. It's compounded 4 times, so we have to multiply that by 4. Therefore, our number of periods changes to 40. So, do you see how our interest rate went down because now we're looking at interest rates per quarter instead of interest rate per year? But our number of periods increased because we're now looking at quarterly periods, and we have 40 quarterly periods of interest payments. Now, we're still looking at future values, so we're going to use a future value formula. We're going to say equal future value, open parentheses. We're going to start with rate. In this example, what's our rate? It's 1.25%. What is our number of periods? In this example, it's 40. What is our payment? We don't have one, so we have 0. What is our present value? We're going to invest $5,000. And again, type, we don't need it. It's not an annuity, so I can close my parentheses and hit enter. And we end up with $8,218.10. Note how the future value is different when interest is compounded annually and interest is compounded quarterly. Quarterly or more frequent compounding than annual compounding will result in a higher number. That's it for this video.